Hello everyone, welcome to this video. In this video, we are going to learn about LSTM using OpenMathAI. So, let's get started. What is LSTM? LSTM, long short-term memory, is a supervised deep learning algorithm based on recurrent neural networks, RNNs, used for both regression and classification problems involving sequential or time series data. Unlike linear regression, decision trees, random forests, and MLP, which process each input independently, an LSTM learns by remembering important information from previous time steps through its memory cells and gates. It consists of an input layer, one or more LSTM layers, and an output layer, enabling it to capture both short-term and long-term dependencies in sequential data. LSTM starts by processing a sequence of previous observations instead of a single input. At each time step, it uses three gates, forget gate, input gate, and output gate, to decide what information should be discarded, stored, and passed to the next step. The hidden state and cell state carry important information through the sequence, allowing the network to learn temporal patterns. During training, the predicted value is compared with the actual value, and the weights are updated using backpropagation through time and gradient descent. This process is repeated for multiple epochs until prediction error is minimized. Imagine we want to predict tomorrow's weather, using the weather conditions from the previous 30 days, including features such as temperature, humidity, atmospheric pressure, wind speed, rainfall, cloud cover, dew point, and visibility. Initially, the LSTM makes predictions using randomly initialized weights. As training progresses, it learns how previous weather patterns influence future conditions, remembers important long-term trends, ignores irrelevant information, and continuously updates its weights to improve prediction accuracy. Over time, it becomes highly effective at forecasting tomorrow's weather. We will use this weather forecasting dataset for the LSTM model. So, let's get started. OpenMathAI. In this demonstration, we use the weather prediction using LSTM model. Click Create New Project. Enter the project name as Weather Prediction. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There's also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There's one more feature, Signal Diagnostics. There's 3 columns. First one is column. It tells which features are in the dataset like inputs and outputs name. Second one is VI if it tells how much correlation of the features. Third column is status if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the LSTM model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines the percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also another feature is added that is trained from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time. the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95 accuracy, almost equal to 95%. Click Fit to Window, you will see three types. Fit to Window, comfortable, compact. Then the clear history if you click, that it will clear the history before its trained model. Another is deselect and select all trained models for export. Click View Curves. You will see the diagram of R-squared residuals and residuals diagram. Click View Math Code. Mathematical model and code generated by OpenMathAI. The preview displays the LSTM architecture, the corresponding source code, and a detailed explanation of how the network processes sequential data. Open the Math view to visualize the complete LSTM model architecture created from your training data. Maximize the Math view window to examine the flow of data from the input tensor through the LSTM layer, readout layer, and finally to the output. The architecture illustrates how each sequence of weather observations is processed through the LSTM's memory cells, hidden states, and gating mechanisms to capture temporal dependencies and generate predictions. The training progress graph displays the training loss over successive epochs. A steadily decreasing loss indicates that the LSTM is successfully learning the sequential patterns in the weather data and improving its prediction accuracy. Once training is complete, OpenMathAI uses a learned LSTM model weights, hidden states, and temporal relationships to predict tomorrow's temperature for new weather sequences without retraining the model. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format. Answer C. FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX Hub. You can choose any of these formats and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.